This video looks at the language and logic of proof, why, our QCAA subject matter, use implication, converse equivalence, negation, contrapositive, use the symbols for implication, equivalence and equality, use the quantifiers for all and there exists, use examples and counterexamples. Our skills in addition to use will be prove and express, and our success will be we'll be able to apply our knowledge to correctly complete the set questions. A quick review of the number system, which you saw in maths methods. Real numbers, or R, we're looking at the real number system at the moment. They can be split into rational numbers, or Q, and irrational numbers, I. We'll start with the irrational numbers first. An irrational number cannot be expressed as a ratio of two integers. Pi and E, our surds, which are square roots of non-perfect squares, and non-exact or recurrent decimals. Okay, so the decimals that have no sense, they keep going on forever. Looking at our rational numbers, or Q, rational number can be expressed as a ratio of two integers. They can be expressed as a fraction. They can be split into integers, our Z, or our non-integers. Non-integers, fractions, or exact decimals. Exact decimals can be terminating or recurring. Our integers can be split into negative integers, zero or positive integers, and positive integers can go down into natural numbers, n. Now, some textbooks believe that 0 is a natural number, so that is controversial, I suppose you could say. I have always done that 0 is not a natural number. So pause the video and think about what all these numbers are. Try and classify them. And pause, and then you can check your work. So 4.25 with the line above it means it's 4.25, and the 25 is recurring. So we know it's a recurring decimal. We also know that it is rational because it can be expressed as a fraction. Negative 0.35 is a terminating decimal, and it is rational because it can be expressed as a fraction. Square root of negative 16 is not real, so we have no classification for that. We cannot square root negative 16 in the real number system. Pi is irrational. 2.6 is a terminating decimal, so it is rational. Square root of 9 over 25 equals 3 over 5, so that is rational. If it was to be a decimal, it would be a terminating decimal. Negative 123 is rational, and it is an integer. 3 over 4 is rational, and if it was to be changed into a decimal, it would be terminating. Square root of 7 is irrational. 1.3 recurring is rational, and it's a recurring decimal. 1.35279045 keeps going. That is an irrational number. Okay, so we have no natural numbers here.